before lunch, we are talking about two things. The first one is the integration between F5 and containerized system like microservices, Kubernetes, OpenShift, Mesos, Marathi. And the second one is Nginx. Now, F5 bought Nginx.com, and this is, I mean, official, okay? 11th of May became official. Cannot disclose. A lot of, by the way. But we have money, so we are okay. What we don't really know yet is how we will completely integrate the Nginx product. We have ideas, and I'm going to share with you some of these ideas because they are official, but of course it's a work in progress, so stay tuned. Talk to F5, talk to eWorld, go to our website, you will find a lot of things, especially in the social feeds like LinkedIn, Twitter. Try to follow Gus, I don't remember the surname, the CEO for Nginx.com. He's publishing a lot of things on LinkedIn and Twitter around the integration between Nginx and F5. Our CEO, François Locodonou, is sharing a lot. The official F5 Networks account on Twitter and LinkedIn, we are sharing a lot there. So you will learn a lot of things in the next months. What I can tell you is that by the end of the year, by the end of 2019, we will officially release a new product, a new F5 product. And this new F5 product will be cloud native and will integrate Nginx software and something else we are developing. Sorry. But first, let's talk a little bit about container, what we call F5 CIS, Container Ingress Services. The name is quite clear. We are using the F5 Big IP platform, an application delivery controller, has an ingress controller for microservices. So I'm going to skip some slides because they are general information like the difference between a standard virtualized server running a monolithic application and a microservices environment running containers. This is what we are talking about. And this is important because one of the most important things I want to share with you, you know that, but I want to be very clear on this. Microservices environment like containers, like containers specifically, but Kubernetes and OpenShift in particular, they are so successful nowadays because they are simply building an abstraction layer on the underlying infrastructure, meaning that you can run a Kubernetes or OpenShift cluster everywhere, in the private cloud, on VMware, on KVM, on bare metal, in Amazon, in Azure, in Google Cloud Platform, in your own cloud, everywhere. You are building this abstraction layer, and everything that is on top of this is common, is homogeneous, right? If you have a deployment file for your application in Kubernetes on the private cloud, you can use exactly the same file in Google Cloud Platform or somewhere else. And this is true multi-cloud environment. This is why microservices are so successful. The other let's say, reason why they are so successful is that in a microservices environment, you can scale up the application only when you need it. So you save money, okay? You just scale up, let's say, the classic example. You have an e-commerce application, you have the login page, and I don't remember in English, il carrello, the cart. The cart part, there are two different microservices. When there is the Black Friday, a lot of people are logging into the application and doing a lot of shopping. So you can scale out only the two components related to the login page and the cart. That's all. When the Black Friday is over, you just automatically downsize and you save money. So what we do in this environment, we do a specific, I will let you will get this slide, so don't read everything, but what we are doing is this. So this is what we are doing. Let me see if I can enlarge this or not. is the microservices environment. We have two components in this solution, two components. The big IP itself, which is outside the microservices environment, because the big IP itself right now is not available on container, okay? It's a virtual machine, or an appliance, or a chassis, never mind. It's outside. Inside the microservices environment, we are providing you with an open source container called a F5 container connector. This is available on GitHub, on Docker Hub, and you can install it in your microservices environment. How does it work? Everything that is happening inside the microservices environment is notifying the container connector, and the container connector is using the F5 automation toolchain APIs to automatically configure the big IP. Okay? I give you an example. We deploy an application in the microservices. The application has, let's say, a front-end part, which is done by 3 containers, 3 pods, as we call containers in the microservices environment, more or less. Okay? So we need to load balance these 3 pods. But in the microservices environment, everything is dynamic. IP addresses, networks, everything is dynamic. So how we do that? How we build the pool member to load balance these 3 pods for the front-end application? We don't know to do that, because the container connector running inside the cluster is listening what is happening in here, and when it knows that there is 3 pods running that front-end application, it will instruct through the API, it will automatically configure via AS3 API this big IP for a virtual server with that pool members. Is that clear? It's quite, let's say, easy as a concept, not very easy to put there, but I will show you this, okay? In this way, I told you there is the east-west traffic inside the container, inside the cluster, sorry. Microservices talk one to each other. And there is the north-south, and now the question is, this is a slide coming from corporate, from F5 networks. I didn't do it. So if I'm calling it north-south, why you are putting the F5 on south? Okay. By the way, the north-south traffic is taking care of the big IP. Now, question. Why do we need to realize an ingress controller on big IP when we have native ingress controller in Kubernetes and OpenShift? Like we have the router in OpenShift, we can use HA proxy, we can use Nginx as an ingress controller. Why you want to adopt an F5 box as an ingress controller for Kubernetes and OpenShift? This is the question, okay? So this is because the ingress controller is typically doing the work that F5 has been doing for 20 years. And we are very, very good in doing this, like HTTP URI switching, layer 7 routing, but optimizing traffic, and especially security. And if you ask me, just tell me one thing why you want to put an F5 box in front of a microservices environment as an ingress controller, this is security. Okay? Why? Because with this API call, and for the crowd of my left, with this API call, you can configure the F5 box not only to load balance the right pool members, but adding an ASM security policy, and web application firewall security policy, an anti-DDoS profile, or whatever you want. Okay? So you are automatically adding security on the important traffic, which is the north-south traffic coming from the internet and potentially dangerous, to your microservices environment, automatically. Does it make sense? I don't want to spend too much time around slides. You will have the slides. So as I told you, I'll give you an example. We have a big bank in Italy, one of the biggest. I'm telling you nothing especially, but they had the fault like 1 month ago on the home banking application, and they stayed out of the game for some hours, which is quite an amount of time for a big bank, you know. So why is that? So usually they deliver all their application through F5. So as soon as they went out of service, we started to, to worry because we are asking ourselves, is it the F5 which is not working? Actually, no. We didn't get calls, hopefully, because the F5 was working right, but what it happened is that they published a new version of the banking, DevOps. DevOps of the bank published a new version, and they went in production without F5. And as soon as they got, they went out in production, the front-end part of the application couldn't stay up to date with the traffic, couldn't scale out properly, and they went down. Okay? Using this kind of solution, F5 as an ingress controller potentially could solve this situation because we are the ones that is doing this for years now. Okay, load balancing the application, etc. So this is just an example of what does it mean to put an F5 box in front of a microservices environment. I'm going to try this live. Let's see if we can do this. I'm not sure, but I will try. Okay. I don't need this. I need this. Okay. This is a Linux with a server in my cloud, in my private cloud, and I am running here in this environment. I am running a Kubernetes cluster. Okay. Let's see which kind of application I'm running. There is just one application running here, which is called Coffee. I don't know what it is. And this application is running with two pods. Okay? Okay. The cluster is running, the application is running, fine, I'm happy with that. Now, what I'm going to try to do is this one. I have exactly this configuration with me. So I have the microservices environment running applications. I have the container connector running in there. And in front of this microservices environment, I have a big IP. Okay? I have exactly this configuration. I can show you the okay, this is the kube system. As you can see here, this is the big IP controller running inside Kubernetes, inside the microservices. It's a cluster, it's a container written by us, by F5, which is available for free and running in the microservices environment. And then we have the big IP in front. Now, I don't need this. I need Chrome. Let's open Jenkins, if it works. It works. I'm not an expert in Jenkins, so bear with me. I did something looking at tutorials, but I'm not an expert. So what I'm doing here, in this environment, I have Jenkins and I have a GitLab server, so a code repository, okay? And in the code repository, I have a source code for an application called Application 1. Can you see it? Application 1, it's just a stupid HTML application serving HTML pages. And I can modify the code here. And then when I am ready to release a new version of the Application 1, I go to Jenkins. Jenkins basically is taking care of my CI/CD pipeline. So what it's going to do is going to take, when I tell him go, Jenkins is going to take the source code from the GitLab server. From this source code, it will build a container. I'm not doing test here. You should do test. If the tests are OK, the Jenkins will put this container in the local repository. I have a local container repository in this environment. Then we go to the microservices environment, the cluster Kubernetes, and we'll install this container into Kubernetes. Okay? This is what is doing this, what this pipeline is doing. Let's try to run it. At the end, sorry, I forgot to tell you something. There is a big IP in front of this, and the big IP is this one. Dancing a little bit while waiting. Come on, here we are. We are in the big IP. It's slow because I'm using my mobile to connect because the Wi-Fi is not working anymore. Sorry about that. So network map. As you can see, you can't see because it's too small, but if I enlarge it, we have a specific area, which we call it partition on the big IP. We have a specific partition on the big IP entirely dedicated to Kubernetes environment, okay? So this partition is the one dedicated to Kubernetes and the one that is getting all the configuration for the application running in Kubernetes. You will see this in a moment. Right now, it's empty. Okay, sorry. KTS. Right now, it's empty. There are no configuration inside here. Okay? So let's go to Jenkins quickly, and let's say build for me application 1. Now, I'm running this manually, but what should happen in a DevOps environment is that the developer is doing something called code commit. So he goes to GitLab and say, commit the code, means that I'm finished with developing the application. I commit the application to the source code. And GitLab can have an hook, automatic hook, to invoke Jenkins. So as soon as the developer sends a commit to the GitLab server will automatically start all this pipeline that I am starting manually right now, okay? So I hit build. Something is happening in the background. As I told you, there is a log here. I can click and go and see the logs. But basically, right now, I'm getting the source code. When I get the source code, I build the container. I put the container in the local repository. I go to Kubernetes. I install the application into Kubernetes. So if everything is going, yes. If everything is going well, now the application is starting. Container creator running. The application is available in the Kubernetes environment. I just committed the code to GitLab, and everything is automatic. This is a CI/CD pipeline. Very simple one, homemade, whatever, made from a networking guy, but yes, it's there. I'm very happy about this, by the way. I'm smiling. It worked. So basically from the code directly in production, dev, ops. Okay, now what we are missing here? Security. Okay. But what happened in the background? Now the application is available. Right now, if you see the picture, imagine a company, and the company has a CTO, and the CTO told everyone in the company that no one is going in production without F5, because we are strong, okay? And the CTO, we bought the CTO, basically. So the CTO is telling everybody, you are not going in production without F5, because we have security, blah, 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 blah. Okay. So now, if we are in a world where we don't have the API ready, like I told you this morning, what should happen now? The developer, with just one click, with just one commit of his own code in GitLab, is in production. And now he has to pick the phone, or to write an email, or to open a ticket to someone and say, hey, I compiled my code, it's already in production, can you please update the F5 box? And then there is a guy that is taking the ticket. After 2 days, goes to the F5 box and start configuring the virtual server, the pool member, and then the pool member, oh, the pool member is dynamic. How do I configure it? Boom, and so on. Do you think it's something that we can do? No. Everybody will refuse to do this. Everything has to be automatic. So what happened? I integrated through the F5 automation toolchain, I integrated the F5 box into the CI/CD pipeline. So if I go to the F5 now, and I hit refresh here, cross finger, I have the virtual server, the pool members there. Why? Because the CI/CD pipeline, in particular Jenkins, at some point in time into this pipeline, invoked the API call that I showed you this morning to build a service into the F5 box. Okay? Actually, it's not like this properly because this has been done, if you remember the slide, this has been done by this guy. Okay? The application started up here. The F5 container connection, the F5 container connector understood that the application is new and is running. It took all the IP address of the pods and updated the F5 box. Now, everything was automatic. I did not touch the F5 box. Now, let's try to see if we can see the application in a better way. Let's go to Rancher server. And you see we have a lot of tools in this world. You can choose your own tools. This Rancher server is one of the tools that you can use to control your cluster, your Kubernetes cluster. So we have a cluster here, K8s UDF cluster, which is my cluster, is active. I can go to the default partition of the cluster. And I see that I have a couple of applications, which are these two applications I can see from the command line. The application one and the coffee. If I go to the application one, I can go here, edit the application, or I can go here and say, hey, you know what? I have 5 pods. It's not enough. Let's go to 10 because I need beer. I need more pods to serve this, this environment because it's the Black Friday is coming and I need power, you know? So we are scaling out the application. So I go here and I say 10. Oh, 20 is too more. 10 pods. Let's upgrade to 10 pods. Okay, they are starting. You see here, the Kubernetes is updating himself. From 5 pods, we went to 10 pods. Some are terminating, some are creating, IP is changing. So I don't know what is happening. But after some minutes, we should end up with 10 running pods in there with 10 different IP addresses. Okay? So let's go to the big IP and refresh the page and see what happened. Hopefully. Yeah. We have now more resources in there, in the pool member. Okay? So the F5 box is in front of this application and is automatically updating the resources inside the cluster where it can load balance traffic to. Right? So for me, networking guy coming from 12 years of F5, this is real magic. I didn't touch the box, and the box is updating himself. And the funny thing, and the most important thing, is that in this virtual server configuration, if I made the right template for the container connector, I can go in here and see that there is no security policy right now, if I remember well. Yes, there is no. But if I provide the correct template that the container connector is calling to provide this application to the F5, I can see here that I have a security policy applies. The DevOps guy doesn't even know that there is security there, okay? But it's there because the CTO said that we need to have F5 and we need to have application security on F5. Okay, any questions? Not you. Yes.
So let's say you have a...
Take the mic.
So let's say you have a legacy application.
It's not. It's red. Okay, say it.
So
Just
let's say you have a legacy application, you already have a pool created.
Yes.
And you want to use hybrid, so you have a legacy and you want to push Kubernetes pods.
Yes.
Are you able to modify the container DF5? It detects and puts it on
Yes.
an existing pod?
Yes. So the question is, can we modify the F5 container connector?
You have something already built?
Yes.
You have an application of 4 legacy applications with subboxes running?
Yes.
But you want to scale with a Kubernetes cluster?
Yes. So you put in the Kubernetes cluster, the application.
But the pool is already created?
On the F5 box?
Yes.
Manually?
Yes.
No, you can't.
To be fresh?
Yes, because everything, as before with AS3, So if you create something manually on the big IP, in this partition, KTS, the container connector is looking at the environment like every 30 seconds. Every 30 seconds is refreshing the configuration on the F5 box. So if you modify this pool and you delete three pool member, after 30 seconds they will reappear because the container connector is updating. This is why when you have a dedicated partition on a big IP box, but you can have a big IP box, virtual or appliance, that is running in front of a Kubernetes cluster at the same time serving traditional pizza box application. Simply put them in different partitions, okay? So you can configure manually services on a partition, and then you have the same big IP box integrated with Kubernetes automatically. Okay. Yes?
Can I ask a question related to routing, maybe?
Routing, okay. Routing, okay.
Yes, as regards partitions on the F5, so each partition will have its own routing table, so it's like an independent entity?
Yes.
Okay, very good.
So right now, I'm just using partition to segregate the configurations, but the routing table is just one because it's a demo. But of course, you can use root domain together with partition, so you define a root domain for Kubernetes, and you put that in the partition, and that's all.
Because we have a similar kind of setup to what you're showing on the slides with Kubernetes as well.
Yeah.
And
You can do that, yeah.
Okay. Thanks.
Okay. And this was the container connector, or CIS, Container Ingress Services from F5. Now, let's go to Nginx, if you agree, okay? Nginx. Bridging the device. These are the slides I presented this morning, so we'll skip them if you agree, okay? DevOps, DevOps, blah, blah, blah. But what we are doing in practice, okay? So this is the message. You can realize the benefit to a unified approach, a more complete portfolio of solution. On one side, the developer side can leverage the Nginx platform on their own, because it's open source, they can download it, blah, blah, blah. On the operation infrastructure, we can continue to use the F5 box as a front end to the Nginx servers, okay? This is the idea. Different application for different products. So the portfolio right now is the traditional portfolio from F5 plus Nginx. Actually, Nginx plus, because as I told you before, we did not acquire the open source. We couldn't acquire an open source company. We did acquire the nginx.com company, which is providing, of course, support for the open source, plus the Nginx Plus, which is an augmented version of the Nginx open source, plus the controller, plus the API management, and plus the caching. So where best to start? Now, we have different use cases. Basically, we are to explore 4 different use cases. How many of you are using Nginx in production? You see? More people than this morning when I asked about F5 in production. And that's good, because it means that now you are our customer. And I'm happy. Welcome to the F5 family. So the first one is what we call ADC augmented, okay? Application delivery and API management. Okay, let's say screenshot for tons of word. So this is the ADC augmented use case. If you are an F5 customer, you look familiar, you will have a familiarity with this part of the vision. If you are a developer and you're using Nginx open source or Nginx Plus, you are more familiar with this part of the vision. Especially because on this part of the vision, you will be probably running this Nginx everywhere, but most probably in a multi-cloud environment. Okay, because you have available in Azure, Amazon, Google, private cloud, it's a container, you can run it everywhere, okay? And this is the good thing about Nginx Plus. The common vision, what we call the ADC augmented, is the F5 box in front of an Nginx controller, in front of an Nginx Plus data plane. Why? Because here you have the good things of the data plane of Nginx, statistics. Nginx, apparently, is running 70% of the internet traffic of the top 500 websites in the world. 70% of the top 500 in the world. Means that they are very good in running traffic, in load balance, in reverse proxying traffic on the internet, okay? We still use this goodness in reversing the proxy the traffic. On the other hand, fronting this environment with a 5, we are adding everything that is good with a 5, especially security. And this is the augmented vision. Security from a 5, okay, and all the data plane from Nginx. Multi-cloud. I told you, Nginx can be used everywhere, can be containerized, can be run in microservices, and so on. So it's very useful for running everywhere. In front of this, you can put an F5 box, like a high-performance load balancer. In this case, high-performance generic load balancer to control everything else in the multi-cloud, okay, as a single point. This is where the co-location example I did this morning comes into place. Again, security is a very important part of this. API management. The commercial version of Nginx is an API management solution, and we are going to explore this if we have time in the last demo. But again, F5 box with the advanced web application firewall we are selling right now is a security suite for API security. So if you sum the two things, API management from Nginx Plus and API security from the WAF from F5, you have a complete secured API management use case. You see the case? API management on Nginx, API security on F5. And of course, Kubernetes integration. Again, I show you F5 as an ingress controller of Kubernetes 10 minutes ago. Nginx has the same functionalities. So you have here basically we are giving you the possibility to choose. Okay? If you are fine in running everything on Nginx as an ingress controller, fine. If you want more, you can move to the F5 ingress controller feature, or you can put an F5 box in front of the Nginx controller ingress solution. So you let the Nginx to do the ingress controller, but you put an F5 in front to add security as a simple reverse proxy to the Nginx. The container connector is still valid. In this use case, is not telling the F5 directly the dynamic IP addressing of the pods, but is telling the F5 where is the ingress controller of the Nginx. So it will automatically configure the F5 to point to the Nginx controller, right? Any questions? Is it more clear now why we acquired Nginx and what we are going to do with Nginx? So ADC augmented, API management, ingress controller, all these use cases are very well suited with the sum of the two products. Some feature on F5, especially security, some feature on Nginx controller, especially the fact that it's truly cloud native and multi-cloud. Okay? I want you to show something around API. We still have some time, yes? Roxana, we still have some time? Okay. Stay with me with 10 minutes more, and then we go for lunch. API security. So let me close the old environment. I don't need this. I need another one, which is exactly this one. Now, access RDP. I'm not sure we are going to use this over the phone. I hope so. Okay. Here we have a big IQ, like we saw before, okay? And there is a simple, let's say, banking application. This is something we wrote, our solution architect wrote just an example of a banking application, okay? Well, it's working like a real banking application, not very complicated. We have the main part of the bank, we have a marketing part, invite your friends, blah, blah, blah. And they wrote basically a specific quick money transfer functionality, which is using API, okay? So if we go here and we select an account, we want to send money to Sven, and we want to send 200 GBP to Sven, and we transfer the money. Done. Okay. Now, in the history, up here, we see that we have been transferred 200 pounds to Sven. Okay, fair enough. This is from the website, you know. So we can do the same. This is an API, so we can do the same, exactly the same, from Postman. Okay, this is Postman. Just to show you that it's not a web transaction, it's not HTML, HTTP, it's properly API with JSON. So with Postman, we do exactly the same. We transfer 200 something to this account, blah, blah, blah. We send it, and yes, 200 okay, and the answer is okay. We successfully transfer to Bart 200 euros. Here we are, okay? Now we go back here, we reload the page, and you can see here, it's in the history. So we did this from an API client, and it came to the history. So we are using this. I'm showing you that we are using the same environment. Okay. Now, let's try to use the same API to explore a little bit, and we say, okay, I have an API and I'm authenticated. Let's do something bad. Let's try to transfer 10,000 euro to Bart. Send. I get a different results. From the HTTP point of view, the result is still okay, because the server answered me, but the status is actually another one. So, failure, and the reason is, please call our customer help desk at blah, 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 with this support ID. The one of you that run the ASM in production will recognize that this is exactly the support ID page sent back to the customer when he's going to do something bad, okay? Now, this is managed by a central management BigIQ, and BigIQ is managing, and basically, as you can see, this is from now, it's 2 hours behind. Yeah, there is a mess about the timing, but actually it's this one. So, full, and the information is here. So basically we block the request, okay, on the API. Why? It's parameter tampering, okay. The concept is it enough to have a web application firewall in front of an API to get API security? And of course the answer is no. Why? Because the web application firewall usually is taking care about HTTP traffic, right? Right now, here, we are taking care of JSON payload, not HTML payload, JSON payload. So this is where the advanced WAF is coming into place. With the advanced WAF, you can send to the WAF the structure of the API, which you can export through what they call a Swagger file, whatever. You give this to the ASM. The ASM will adapt the JSON structure to something it can understand, and basically reusing the security policy with parameter tampering to block something on the API. This is doable because the advanced WAF of F5 is acting as a real API security device. So we are putting F5 in front of the API, we can realize API security. And this is F5, big API, the traditional one, okay? Any questions? Now, how do we do API management? API management is a different thing, and we are doing this with Nginx Plus. Nginx Plus has an API management engine. So let's go to something different. And then I finished. Where is it? Okay. Lab guide to the Docker host. Docker host. Lab guide. Okay. Then we open the. So here we have. We have a Docker host which is running the Nginx Plus data plane has a container, okay? We have another Unix, Linux box running the Nginx controller, okay? And then we have the client. I'm now going to connect to the client. Access method, SSH. Let's take this. Okay, let me take the instruction to cut and paste the commands. So basically, I show you the controller of the Nginx Plus. Nginx controller. So who are using the Nginx controller? Okay. This is the commercial product, right? You have to buy it. It's quite good because basically with the Nginx controller, you are adding Nginx data planes, and this is one of these. This is the one running in the other Linux server. It can be in the cloud. It can be where you want, okay? And you can have multiple there. You can control multiple Nginx Plus from the controller. Right now we have just one. And on this one, we are building the API management. So I did part of the job this morning because otherwise it takes too much time. So what I did is to, okay, I'll show you. It's a very simple API. Okay. No, it's before. Where is it? Okay, so we have this one. I'm querying the API right now as a client. And I'm pointing, so this 10.1 to 20.5, this IP address, it's not the Nginx. It's just the direct server running the API, the web server running the API, okay? I'm asking for a Formula 1 drivers Alonso, and it's getting back to me an XML file with all the details of Alonso, okay? And I can ask Alonso plus .json. And this is exactly the same information as a JSON file. Much modern, much more usable, you see? This is a JSON file. So I can ask Alonso or alonso.json. And in both cases, I get an answer. In the first case, it's XML, and in the other case, it's a JSON file. And this is the API. Very simple. What I did is into the controller API, I built an entry point. For the entry point for the API management is exactly like a virtual server in the F5 box. It's the IP address where I am, the entry point where I am, from where I am accessing the API in the backend. And basically, the entry point is pointing to an upstream groups of servers, and this is basically the pool with the pool member, okay? I'm matching the F5 language with the Nginx one. And so we have F1 data and the FY admin. And then we have an API definition, a dev environment with API definition, where I simply say that, come on 4G, it's where I say what to do when someone is requesting one API or the other. Here we are. I have no policy right now. I have a route. So every time I ask for circuits, seasons, circuits, constructor, driver, I go to the backend in fy_data, and if I ask for season, I go to f1_admin. They are the two, let's say, pool I have configured before. Now, this is working, of course, because I can actually point here to the, so as you can see, I'm pointing to f1.f5.lab, port 8081, and this is exactly the entry point I just defined on the Nginx controller. By the way, the Nginx controller is a centralized device that is talking to the Nginx Plus engines through API. Everything is API, okay? So I'm taking this and, oops, sorry. And of course, I'm getting exactly the same answer I got before. I'm just, like reverse proxying the information to the real API server. Okay, it works. Now, let's do something else. Let's do a rewrite policy, okay? Right here, if I write just Alonso without .json, I will get an XML file. Now I have in front of this, I have an Nginx Plus controller, an Nginx Plus that I can use to do something on the API, okay? It's a layer 7 proxy. So what I can do is to configure some rewriting, for instance, like this. I think it's here. Here I rewrite something, and I say that, I don't remember, sorry. I have to say that all this kind of stuff. So when the customer asks for this, you have to do $1.json. What I'm telling in every time the customer asks for something with or without JSON or XML, just ask for the same variable .json. Okay? And then we have to add another one, which is this one. Okay. I have to rewrite now. I publish this. I wait a little bit. And then I'm going to say exactly the same command I sent before, which is Alonso without JSON. And I still get the HTML, the XML, sorry. Still publishing, probably. What I should got is that the rewrite rule I just put there is taking Alonso and then substitute it with alonso.json. So even if I want to ask for XML, I'll always get the JSON one. No, it's not working. Never mind. Okay. Push failed. Nice. Well, first issue on the morning, I think it's good. Let's try again. By the way, I just wanted to show you that in this specific screen, you can have different policy. Like you can do URI rewrite. You can authenticate the API with a key. You can rate limit the connection to the API, and you can do JWT authentication, all on the Nginx platform. So even if the developer did not write anything about this, you can implement basically rewriting and authentication on the API management of the Nginx Plus controller. And in front of this, you can put the F5 box to do API security. And this is the complete API management security platform delivered with F5 Big IP and the Nginx Plus controller. And that's all from my side. So thank you very much for listening to me all the morning. I hope that it was interesting. We have another quiz right now.
They want to do it?
Do they want to do it? Other two Alexas are available. It's very quick, quicker than the other one. So let's go to...
Obviously, the rule is you can only win one, so you
Yeah.
can't play. Okay, fair enough.
No, if I mean, we can go to second and
Yeah,
third
exactly.
and fourth. Yeah. So let me see where it is. This is quiz 1, quiz 2. Sorry, I need to remember to, yeah, okay. Okay, 915097. Waiting for players. Much faster than this morning. Eh? They are learning.
They won the speaker.
Emilio. Wow, Italian name. Okay. 30 more seconds. Anyone has troubles? Okay. Let's go. Ready? 5 questions. Speriamo che siano giuste.
The Nginx solution, Nginx Plus
Plus.
solution offers
Lightweight application delivery platform. All of the answers are correct. An API management platform, a web server.
I know that.
Do you know that?
think so. Amazing, isn't it?
5 more seconds to answer. Yes, all of them.
I thought I did. The API management use case, what can FI Big IP bring into the picture?
So we are in the API management use case. This is easy, because I just told you. I expect 100% correct answer here.
Otherwise, there'll be no food.
Oh, come on. API security is the correct one.
Hugh.
Who's Hugh? Wow.
Good, doing well.
But loudness is there.
With F5 and Nginx together, we can select 2.
Select 2. Yeah.
You only can select one. You cannot select one.
Oh, really?
Yeah?
Ah, my bad, sorry.
Yeah.
Choose the best one. Sorry about that. No, it's 2. Ah, you can only select 1. Okay, sorry about that. It was...
Still Hugh in front. Which of these Big IP software modules is in charge of the API security?
API security. Which module? You know that, right? Già quinta. Advanced WAF.
Right, very last one. Let's see what the situation is. Ooh,
Head to head.
interesting.
XPS. Who's XPS is going to win?
XPS. Good. Very last one. In the ADC argument use case, F5 and Nginx are providing these products.
So the use case is ADC augment. And the right one is the green one. Big IP, Big IQ, Nginx Plus, Nginx controller.
Right, let's see who has won.
Ooh, Gerson and DF.
Gerson?
Gerson and DF.
Are you
two of
two
them, yeah. Very well done, guys. Thank you very much.
Right. Thanks ever so much for participating here today. I know it's been hard,
Yeah, I know it was hard. Sorry about that.
but I hope it's
Lot of
been
stuff.
useful. There'll be lunch served, and we're around for any questions.
Yeah.
Thanks again.
Thank you. Thank you very much.
Thank you for coming over. As Maurizio said, thank you, Maurizio, thank you, Paolo, from our side. Thank you for coming over. We're going to have a quick lunch now, so if you're not in a rush, have a quick lunch with us. It will give you ample time to network with either Paolo, Maurizio, or the whole team. We've given you a feedback form at the beginning of the session. If you can cordially fill it in and hand it out on your way out, we would greatly appreciate.